All right, y'all. So what we're going to talk about now is we're going to talk about the Caret package. So the Caret package is actually something really, really cool. It's going to speed up model selection, especially around cross-validation. So we're going to load up dplyr. We're going to load up Caret. Now, the Caret package is again something we can use. Now what I'm going to do is I'm going to load up ALR4 and we're going to look at the min land package. Again, if you're used to seeing all of this, we're going to show chunk output in the console, and we're going to remove output here just so you can see it. And I'm kind of using this as a .r file. So let's look at summary min land just so you remember what it is. This is Minnesota land prices, and we're using acre price. Now I'm going to look at the dimension of min land, and let's just look at a real quick table of productivity and tillable. So here's the ones that are false. We're looking at the NAs in productivity and the NAs in tillable. So there's a cross section of about 1,000 observations that are true in and when I say true, uh that have NAs in tillable and productivity. So they weren't productive and they didn't have tillable land, which makes sense. So only 1,000 of them didn't have those things. So if we plot productivity and tillable, let's see what that looks like. So really, here's what you're seeing. So these are the things that were both productive and tillable. So you can kind of see what this looks like. Um, Not a whole lot of stuff going on here, right? Doesn't look like there's a trend there at all. So what I'm going to do, we're going to take the ninth column out. So what's the ninth column? One, two, three, four, five, six, seven, eight, nine. We're going to remove productivity. Um, so I'm going to say minland two removes productivity. And we're just going to look at the summary. And so you can see that's the data set with productivity out. Now, the other thing I'm going to look at is acre price. I'm going to look at the log of this again. So we're going to look at acres and acre price. We've dealt with this data set enough to know we're going to take the log of both of those. And if I look at the plot, you'll see this starts getting me to some sort of linearity, right? Or at least something close enough. Now, remember, there's a ton of, oh, excuse me, I've got the hiccups there. Now, I'm going to show you a couple different functions. The first one I'm going to show you is create folds. Now, this is a really, 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 really quick way to create the folds for five-fold cross-validation or 10-fold cross-validation. Create folds, what you're giving it is you're giving it your response variable. You're giving it the number of folds you want. It will return it in a list. And it says return train. So you can break it up. Now, I'll show you how this works. Okay. Now, if you want to do list true or false, I'll show you how to do this and we'll see what it looks like. All right. Now, here's what we're going to do. I'm going to set my seed so we can get the random number generator right. I'm going to NA omit this data. We're just going to say if it's not a complete data set, it doesn't matter. So minland 2. Now, let's take a look at what this does. Remember how I had to use that for loop before? What I'm doing is I'm saying acre price is my response. I'm going to create 10 folds and we're going to say list equals false. Now, when we do this, watch what it gives me back. If I said sets, right? If I said sets, let's look at head sets. What it's doing is it's saying the first observation is 5. Second observation is 10, 3, 1, 2, 9. This is the fold it's in. Now, watch what this does. If I say list equals true, watch what it does. It says this is the data set for fold 1. This is the data set for fold 2, 3. It's returning the training set. Okay, not the test set, the training set. If I say list equals false, it's returning what set the observation is in. So if I come up here, run it again, what it's doing for me is it's giving me the sets back. So I created my folds. Now all I have to do is I can set my mean absolute error. So here's what I'm doing for my models. I'm coming through, I'm setting my M1 and M2, and I'm going to fit a bunch of models. So I'm saying identify what fold I want. Here's model one, here's model two. You can see there are different models with different things in them. All right. Different models with different things in them. All right. So this first one, we have log acre price, log acres times region times year. You can see this is plus region. So the first one is we're looking at an interaction with log acres and region. We're saying that's the difference. We're removing the kth fold. We're going to predict on the kth fold. And then we're looking at the absolute error. So calculating my error for the kth fold, looking at the absolute, and then summing it up and adding it to our scoreboard for both of our models, right? So this is our scoreboard. We're calculating the error, right? We're setting the error to 0, calculating the error for that fold, and then summing it up, all right? And then at the end, we'll take the average. So we're going to run this. We've got our sets, calculating this. We're going to run our for loop. It ran. We'll calculate the mean. That's for MAE1. That's for model 1. That's for model 2. The lowest one wins. We said model 1's the best. So adding this interaction matters. That's all we're doing. That's all we're doing. So rather than having to go through and create those folds and make our own for loop and divide the data up in this random way, create folds does it for us really, really quick. Okay. And then all we're doing is running the for loop to get it to matter. All right. Now, we can do it again. We can do it again in a slightly different way. All right. In a slightly different way. Now, if we want to do it this time with the lists, here's how we would do it. I'm going to set my folds again. Now, this time I'm going to look at it and I'm just going to do it with the lists. Now, notice how I do it. I don't say lists equal false. All right. Look up here what I did. I said list equal false. This time, K fold. This time, all I'm doing, I'm going to set it up. Now, look what I'm doing. I'm saying get out equals sets K. Get out equals sets equal K. All right. Now, return train equals false. All right. So this is the test set. So what it's doing is it's removing the test set. So it's minus get out. So all we're doing is saying get out. So when I say sets K, it's telling it what observations to pull out. All right. So all we're doing is removing that set. So it's pulling out those. It's saying, get these observations out of there. These are the observation indexes. All right. So when we run that, all we're doing is this is doing the for loop to define what observations go where. This is doing that for us. So this is defining the observation numbers. All right. And this is defining the test set, not the training set, the test set, because by default, return train equals false. So all we do, we come in here, we run it again. I'm going to start up here for us. We return it all again. We'll wrap this in mean. We'll wrap this in mean. And you see it comes out to the same numbers. And that's the important part. It runs it all for us there. All right. Now, you can see how all this would work with piping. All right. You can run it with testing and training data with piping as well and see how it would all come out. All right. So that's what we're doing here. We can create folds again with piping, and you can see how all that works. Now, I want to show you one other thing. And this is how actually the Caret package works at a larger scale. We're going to look at another data set called S market, and this is the stock market data. So really quick, I'll run you through S market. So S market is the S&P stock market data. It's daily percentage returns for the S&P 500 between 2001 and 2005. So what we're going to do is we're going to actually use something called the S&P 500, okay? Now, Caret does a lot of things. And you'll have a ton of different methods in Caret, all right? The whole point of Caret in general is you have this thing called train. Train is your default method, and you'll have all these methods. There are these methods, and I'll post Caret and I'll post some different things about Caret. But the basic idea around Caret is you have these things called methods, and they're the default way you do things. Okay. To train something in Caret, you have to have something called train control. And in train control in Caret, if I do help train control, you'll see you can come up with method, you can have p equals 0.75, you can see all of these things. All right. For a method, you can have cross validation, leave one out cross validation, or repeated cross validation. Now, the ones you all know are leave one out cross validation, or LGCOV for repeated training test splits. Now, LGOCV, all right, that's random splitting, all right. LGCOV, or none, if it's only one model for the entire training set. That's current state. That's just like fit and LM. All right. So if you say method in the fit control right here, that's what it's going to do. So I either want you to use CV, LGCOV, or LOOCV. That's leave one out cross validation. All right. Now, what we can do is we can create a new data partition. What this does is this just takes like a 75-25 split. So this is going to create a holdout sample. This is how we validate models sometimes. Now, as you get bigger into machine learning, like as you would go down in different classes, so in Buddha 530 or in Buddha 535, you can get more and more, you can get deeper and deeper into things, okay? Now, as we do this and as we come through this, I think one of the big things to see and one of the big things to say is how you would approach this. All right. Now, what we can do and what I'm going to do is I'm going to fit a 75-25 split. I'm going to withhold 25% of my data. All right. So what I'm going to do is the S market data. If you see what this is, you're going to see this is direction up or down. And all it is the sign of the today. This is the percentage return. Okay. This is the year of the data. This is the 1 day lag, 2 day lag, 3 day lag, 4 day lag, 5 day lag. This was the volume of trading. And this was the direct or the percent return today. Okay. And this is the direction it went. So I'm just going to remove the direction. I'm going to remove 25% of my data and it's going to randomly do it. I'm going to create the direction on today because that's going to be my prediction. All right. So it's going to do a 75-25 split. I'm going to create something called new train, which is the data set I'm going to teach my model on. All right. That's just going to be my training sample. I'm going to create a train control. So I'm going to use cross validation on 10-fold cross validation. Okay. And then I'm going to say train today tilde period means use the rest of the data as my predictors. I'm going to say data is new train. I'm going to use a method called LM step AIC. This is a pre-programmed or stepwise or backward selection using AIC, and bring me my best model using backward selection AIC using fit control. Okay. Now it's going to do all of that for everything. Now it's going to, inside of this model, it's going to have something called RMSE. We're going to say predict using M1 against new train today. RMSE, predict M1 using new train today. And what this says use the best prediction. It allows me to compare my prediction with M1 to train today. RMSE is the easiest way to do prediction accuracy. Okay. So rather than me having to come up here and do all this stuff, RMSE or this right here, RMSE would do it for you. It says, here's my prediction, here's my actual. RMSE does it for you. All right. Now, this is LM without stepwise. Watch what this does. Runs everything. It says LM without stepwise regression. This is the actual number. Here's it with AIC. It says the LM by itself does best. So the AIC reduction model is there. Now, this is what Caret does. All right, this is what Caret does. Now, there's a few other things in Caret that I'll show you real quick. So as you look at the Caret package, right, you'll see a whole lot of different models, and I'll show you just the available models you have. You have all of these models. And if I just show you LM step AIC, and I'll tag this article because it runs you through everything you can do in Caret. This shows you what you had access to. It says the method was LM step AIC, and it says linear regression with stepwise selection. So it's not just backwards, it's there. But if I show you LM, right, it says here is that. Here's what we just used. You could have used LM, you could have used LM step AIC. But these are all the methods you have access to. All right. These are all the methods you have access to. This is every model you have access to in Caret. You just don't have one. So using what we just did, the methodology, and I'll go back into R for a second here. Using this function right here, we could change the method itself to any of those models, and it would open up an entire class. So as you learn more and as you do more, this step with Caret opens up an entire functionality for you. So I'll set up and I'll tag the Caret document right there so you can read more and you can do more. But from our perspective, what we want to know about is we want to know about the create folds, and we want to understand what we're really getting at is this train control idea allows us to go one step, two step. So we're allowed to see how it works. Okay. So we're allowed to see how it works. So again, if you have any questions, let me know. Let me know if you need anything. Let me know how I can help.